Good afternoon and welcome to the fourth of fifth Mentor Lecture. This is a Mentor Lecture sponsored by the Arctic Climate Modeling Program. Today our guest is John Lingus of the National Weather Service, and his topic will be the title Data Display. John Lingus has a degree from Oregon State University in Atmospheric Sciences. He's been very involved here in Fairbanks. He's been working with the National Weather Service since 1980, and he does a lot of different things involving the community here in Fairbanks. He provides tours of the National Weather Service Forecast Office to school groups and makes presentations in school classrooms. He also participates in Geophysical Institute-led education outreach programs for middle school students, such as science and math enrichment programs. And he serves as a science instructor for the Arctic Climate Modeling Program. Those are just a few of the things John does. He's going to continue with continuing the list of some more things he does and start with the lecture right now.
Well, good afternoon, everyone. In addition to what Hal shared about what I do, some of the main functions of my job in the National Weather Service is to be the customer outreach coordinator, and in that role I've done some visiting around the state. In particular, I have visited western Alaska from time to time. The visits have usually been for a few hours to several days, depending on the location, but I have visited places such as Nome and Unalakleet, Diomede, Gamble, Wales, and St. Michael's, to name a few of the places. And it's always an exciting and pleasurable time to be there to get to know folks with what little time I have there, and to understand how the weather affects folks out in the Bering Straits area. So the other thing that I do is I track the storms that come through after the warnings have been issued to kind of grade on how our office does with issuing warnings and watches and advisories. And then there's a lot of things related to how we function as an office, a lot of internal things, procedures and policies that I'm help develop along with some of the other management staff. So I have a full plate. It's every day is different. It's always changing and dynamic, just like the weather. And so that's just a little snippet of what I do. Well, let's start with data display here. And I'm going to be going back and forth between a PowerPoint presentation that you will see and this camera shot of myself. And so I'll just go ahead and go on here now. Well, the first thing I want to talk about is why display data. It helps in displaying data to compare an item, either to compare it to similar items. For instance, you may want to take a survey of how many children in your class are out sick today. That could be a piece of data that you collect. Or you may different items. You may what sickness does he that's out sick today. You may want to compare the item with, that is, how many people are sick, with the environment the item is in, and that would be how many children in town are sick this week. Or sometimes you want to look at the big picture with regard to this item, in which this example we've been using are people who are sick today. You may want to ask how many children in the world are sick this week, if you can get a hold of that type of data. Or you may want to ask how many children in the world can get medicine to make them well. So there's all types of ways to use just one piece of data as you get more data to compare it to. Another reason to display data is it helps us to compare items quickly that we're trying to measure. For instance, I think of this line that says, a picture is worth 1,000 words. Our brains often process information more rapidly through our eyes than through our ears. Now, there are some exceptions. If you hear some verbal information that's in brief and urgent, like run or get to higher ground, that'll process real quickly. You don't need a picture there as long as you trust the source that it's coming from. But displaying data helps us to draw conclusions quickly about the data so that we can First of all, we can see if an idea we have agrees with the data that we've recorded. For instance, maybe you have made an observation after looking at the tide during the summer months. You notice that a really high tide occurs once a month. You've taken daily measurements of the tide, and you've determined that at least once a month the tide gets really, really high. Well, then if an action should be taken based on that data. For instance, once you know that a really high tide occurs once a month, you might be thinking about the boat that you have, and you would determine that a really high tide, whenever it occurs, could take out my untied boat. Well, then you may want to take action based on that data. For instance, you might want to say, I tied up my boat before I left on a long trip because I knew a very high tide would occur. Or you may want to involve other data with the data you've already taken to make sure that the action you're thinking about taking is really appropriate. For instance, you know that a high tide occurs once a month, but in talking around with folks, or from your own experience, you realize that there's storms that hit at any time, so that you now decide that a storm can come at any time and wash away my untied boat, so I'm going to always tie up my boat. All these decisions are based on data that you gather. Whether you're looking at real tidal data or you're talking with people generally to find out historical things, but that's all data. I'm going to talk about the types of data displays. One is pictures. These are drawings that you may use. A common example of data display is maybe in the newspaper or on TV when you watch about the weather. They'll have little pictures of the expected weather for each day out for the next 3 or 4 or 5 days. They'll have a cartoon type of image of either sunshine or clouds or rain or snow, that type of thing. That helps you quickly realize what the forecast is instead of having to read a piece of paper or on the internet that says mostly sunny or rain tonight or snow today or windy tomorrow. Another type of picture is photographs. They help us show how things change. One of the things I've thought about is that recent photographs that we take from where we're familiar with, we tend to look at rather casually, but older photographs or photographs from some other place seem to have more data, even though both photographs taken near to us or something that's foreign to us still have a lot of information on it. Pictures as data are signs. They tell us what to do, what not to do, where to go or not to go. They're usually oriented towards safety, providing information to help us reach our goals or our destination. A traffic sign, or for those out in the southern coastal communities, beyond the Bering Strait, there's information signs posted along the coastal zone about tsunami hazards, for instance. It says if you feel an earthquake, go to higher ground or travel inland. That's an example of a picture telling a person what to do. The other type of data is related to maps. Those are...
Michael has been using Google Earth for satellite pictures.
That system, Doctor, Google Earth, it's a set of satellite pictures. You can zoom in on any portion of the Earth, and we can get data about what the area looks like, what the terrain is like, and stuff like that. We've been using that to collect data on areas.
Yes, I have heard of Google Earth. I have not used it personally, but sounds like a great tool. Going on with maps, there's a variety of ways to play. One is through points. That's a dot on one place that represents something that's represented, usually cities or airports, maybe where a certain type of equipment is, numerical value of some item that's trying to be plotted, like a weather parameter or ocean parameter or land parameter. Sometimes they plot population densities, or either of people or of other items or animals. Other things, lines that connect points. Roads and rivers are depicted by lines, airplane routes rather. And then another important thing about lines that we tend to use a lot in weather forecasting are contours, or we use lines of equal value. So these are lines that are drawn that connect the same value of an item across the area of the map. How things are changing over a certain distance just by connecting the same data values. An example of this is topographic maps. So if you go out away from the village or town to do hunting or fishing and you use a topographic map, those have lines of equal value. Various weather charts that you may see are like that too. Or ocean charts that show how deep the sounds are, Norton Sound or Kotzebue Sound. They have lines of equal depth. Another item in the maps are polygons. Those are like areas with closed boundaries. These are like outlines of various things. Maybe they'd be a county or a state or a borough or even a national boundary. Sometimes it's more administrative, like it may be a map of western Alaska that shows the outline of the Bering Strait School District. That's a polygon. Or any outline of any national parks or refuges or preserves. Central polygons like the region of each native Alaska language that can be plotted on a map. Or sometimes it's more of the natural or biological variety, like where are certain shrubs and trees across Alaska. Maybe they'll outline an area of that. Soil types or different climates. All these things are like polygons. I can send out to you all. We'll come with an example of some data displayed for meteorological purposes. Something can be very simple to just having an outline of the state with one value of a weather parameter. In the example here I show in the PowerPoint, there's one of wind chill. Or then you can get more complex and show around each weather observing site various types of data, like a temperature and a wind speed, a wind direction, a pressure. All these kinds of things can be plotted all at the same place and provide a lot of information. You can even do like satellite photos of weather systems and lay those on the surface observations on top of a satellite photo to help provide more information to understanding what's going on with the weather. The data is what I call tables, charts, and graphs. These are useful for displaying data, in particular, data that's about a lot of similar items. Usually occur seeing how they change over time or over a distance, or maybe change in their amount among each other. Locations, you may plot the data from one location against the data of another location. The data are best for finding a real specific number to act on. The students in your class, and you could make a table of what they drank each day of the week. You could tally that up, get a total for each student, and that would give you some information that would be helpful. You could, a physical education specialist in the Bering Strait School District are wanting to determine. It's about the end of the school year and they're preparing for the next one, and they want to be sure that every school is prepared for basketball season, so they call each school and find out the number of basketballs that they have that are still in good usable shape, and they have a quota to want to try and make sure every school has 8 basketballs. So they could make a tally, they could make a table rather, of each school and the number of basketballs that they have now and how many they need to make 8 basketballs per school. And the total there of among those schools would be the number of basketballs that the physical education specialist would have to order and then distribute to the schools. Now, I don't know if that's how you order basketballs out there in the Bering Strait, but that's one idea I thought of here. And a table really lends itself quickly to finding out the number that you need to take action. Graphs are another way to show data, and they are particularly helpful. Again, it's like a picture, which is worth 1,000 words. Here's a graph here of 3 different elements over 4 different days. This is what we call a bar chart. And this gets back to, this is what I plotted out here, is that example I talked to you about, with how many, or which kids drank how much milk each day of the week. And I just chose 3 days of the week, Monday, Wednesday, Friday. But each different color on the graph, if you can see the color difference, is a different student. So then at the end here, you can see the total number of glasses of milk drunk each day. Another type of display is a chart, and here I have a display of the average temperature, well, let's say for 1980, just the year 1980, the number of days that the average temperature was greater than 40. Well, the light blue are the number of days that Nome had above 40 degrees for an average temperature. The dark blue is Kotzebue, and the blue-green here is Unalakleet. And you can get an idea from this graph how it is, how many of these days are relative to one another. And so it's kind of helpful. But if I asked you how many days, it would be difficult to tell with this pie chart. But pie charts are really good for just showing relative amounts, how data compares one to another, if that's what you really want to get across. I got the same information, and this time I did a bar chart. Well, in this bar chart, now you can get an idea. It has the total values on the side there, and it has Nome and Kotzebue and Unalakleet listed, and you can see now that the number of days that the average temperature was above 40 in 1980. Nome had the highest number, followed by Kotzebue, and then finally Unalakleet had the lowest number. Now there's markings on the side as to how many days, but it's not real specific. It's by every 20 days. So if you really had to know the number of actual days that Unalakleet had compared to Nome, you could maybe make an estimate from this graph, and that would be helpful. But you would probably want to go back to the table that it was created from to find the exact value, because in there you would discover that Nome had 130 days where the average temperature was greater than 40, while Unalakleet had 81. Another type of graph is scales, and this is the last one we'll be talking about. They're useful to display the value of one item over a range of possibilities, and we can think of using scales in different ways, like a fuel gauge is a scale, a speedometer, a compass, thermometer, any of these types. And I have just an example here of some of these scales. They may be hard to see, but I have a thermometer here. That's a scale where it's really cold here, and it goes to very warm. I have a wind indicator scale that shows how fast the wind may be blowing. Here's a speedometer here, how fast the vehicle you're in is traveling. Compass is another type of a scale, something we don't necessarily think of as a scale usually, but it shows where true north is and the relationship to true north by this red needle with markings around. And then we have something more familiar to all of us, are gauges. This is a dual gauge for oil pressure at the top and fuel level at the bottom. That's a really important gauge for all of us. We want to know how much gas is in our snow machine before we take off on a trip, or in our car or vehicle if we go driving. So this is just another example of a scale that can be very useful and practical every day of our lives.
How long were you working for the weather department?
I started back in 1980, so it's coming up on 26 years.
Well, John, we have this question that came into us. The question is, why did you choose your field as a profession? Why did you choose being a meteorologist as something you wanted to do with your life?
Well, that's a good question. I can try and give you a little bit of history, because I really never decided to become a meteorologist until the end of my first year in college. And a lot of people enter meteorology thinking they're going to do so from the time they're a kid. They're your ages out there. They got interested in the weather at an early age and decided that's what they're going to be, and sure enough, but I took a little slower track. It took me a while to discover that this is something that was interesting and fun. I have not been disappointed since I chose that in my freshman year of college.
What do you like most about studying the weather?
Well, that's actually a pretty hard one. There's all kinds of different facets to weather, as you know, because you have the aspect of clouds, you have the aspect of winds, you have the aspect of precipitation types and where they fall. So there's always something complex and different about the weather. And the other thing is that it's always changing for the most part. I know some days out in the Bering Strait may seem just windy one day after the other, but there really are subtle changes that make each day unique with weather, and I think that's a big appeal and interest, is that each day is different. So whenever you sit down, for instance, I at times work the forecast desk that prepares the forecast for northern Alaska. We have 11 folks that are dedicated to do that, and sometimes I fill in for them. And each day is different when you sit down to write forecasts. You have to study and look at things and try to determine what's going to be new.
How the weather change the global warming?
Well, we have changes in recent past. For one thing, the sea ice has not moved south as early. There's other changes going on as well. Temperatures have changed some. It'll be interesting to see how things go, whether this is a long-term trend. There's also cycles of how the Earth behaves with weather and climate, coming periods of 20 years or so. And that's part of this complex as well as we study climate.
John, we have another question. What data do you use to forecast the weather?
Well, there are several types. We use satellite information, we use radar information, we use surface observations like I was talking to you about earlier. These come from land stations like at Savunga, Gamble, Unalakleet, St. Michael's. All these places have weather instruments, as well as that are these type of weather instruments were installed by either the National Weather Service or the FAA. And then there's other weather instruments out there that are installed by other means or other companies or outfits that we also get some weather information from as well. So the land stations are a big part in understanding the weather. I said satellites and radar. There's balloons that are launched once or twice a day, for instance, that give us a shot up through the upper atmosphere. That's important as well. And all these things go into our analysis of the weather to try and understand what's going on. And all this data also is fed into high-speed computers to try to model the atmosphere in the future.
And we have this question. What's the highest and lowest temperature that you've seen?
That I've personally seen?
Yeah, personally.
Oh, okay. Now, do you mean that I've experienced or that I've just seen by
You've
working
experienced. I think they want to know that you...
Oh, okay. And, of course, you mean in Alaska.
Could be anywhere. It just says the highest and lowest.
Well, the highest and lowest. Well, let me start with Alaska. Okay, the highest temperature I've experienced in Alaska, I think, was about 92 degrees back one summer day in the 80s in Fairbanks. The lowest, I suspect, was probably about 50, I think it was probably 55 below. Maybe it was even closer to 60. And I think that was that was probably January of 1989 when it got really cold over Alaska. And I'm sure it was down to minus 55, and it could have been a little bit colder. I was not living out at North Pole, which is nearby Fairbanks, and of course folks out there were saying that it was even colder than the Fairbanks temperatures of 55 below. Beyond Alaska, I think I have experienced something like whatever they say it was with a heat index, but I think it was like 105 degrees, and when I was at a training course in Kansas City, that was when a big heat wave came through in 1995, and that was downright hot.
And another question about just the weather out towards Bering Strait. The question is, why is it so windy out by that school district?
Well, part of it's with the general climate patterns that develop. One of the things is during the winter time that high pressure naturally forms over either Russia or else over the Arctic Ocean to your north. And in either place with high pressure there's usually low pressure that moves along the Aleutian chain, or eventually later in the year it ends up going into the North Pacific and the Gulf of Alaska. But if you have low pressure along the Aleutian chain and Gulf of Alaska with high pressure over either Russia or the Arctic Ocean, you're going to have some amount of northerly winds across the area. And the Bering Strait is, of course, favored in some ways because right down near the land and the ice, the geography is constricted there by the Bering Strait, and that helps to make things windier by funneling the air currents in a tighter pattern, and then thus the wind speeds are higher.
The question is, what is the most difficult thing to predict in the weather in Alaska? Scenario you have, would it be like a big storm in the fall, or a winter storm, or what scenarios are most difficult?
There's a couple things that are difficult in forecasting. One is in the autumn time, when we're making the transition from the warmer season into the colder season, we need to know how much intensity of the storms will bring the precipitation to western Alaska in particular, is what I think of. And the real problem there is whether the precipitation will be rain, because it's still warm enough. And in regard, has the land gotten cold enough so that if snow falls it'll stick? Or is it still warm enough that it'll melt? Then another problem area is probably more related to the interior of Alaska, but that's precipitation. That is, it's already cold at the ground. It may have actually warmed up some in the air. Air might be above freezing, but the ground in the interior remains very cold all winter long. And so knowing when freezing rain occurs is really important, because that ice forms on all the traveling surfaces like roads and walkways, and it can make traveling very, very dangerous.
The question is, what is the most common way to display data with the weather? So what are some common, I think you touched on that in the lecture, but maybe if you could go a little more in depth with ways to display weather data.
Well, one of the things that we like to use as meteorologists is to lay different types of data on top of one another so that we can see how different perspectives of the atmosphere all look. So, and I have an example here, which maybe we can zoom in here, Hal. This is an example. And I don't know if you can see this very well or not, but there's some red markings on there, and those are the surface data. You can even zoom in more if you can. These red markings are the surface data, are pressure fields that are analyzed. the background is actually a satellite photo. So you can see the Seward Peninsula there. And then the yellow markings are actually the outline of the coast as well as the zone, forecast zone boundaries. So we've got a lot of different types of data plotted on here. It's not just the weather data, but it's other land and geographic information that helps us do our job easier and quicker to try to analyze what's going on. Because one of the important things in doing a weather forecast is finding out what's going on now and then making extrapolations about what will happen in the future. But if you don't know what's happening now, making those extrapolations for the future can be really erroneous.
John, part of our interest with this lecture series is getting students interested in science and even thinking about maybe careers in science. What are some different options for jobs that are, in the field of weather or atmospheric science or anything like that? What are some different types of things that people do?
Oh, good. Yeah, there's a number of things. And it's the obvious one, of course, is being a meteorologist. And for that, you need to, after finishing high school, need to go to college and get a bachelor's degree in meteorology, or some schools call it atmospheric science. They're one and the same. With that, you can be employed as a meteorologist in various places. You may want to get advanced degrees if you so desire, but you don't need to. To be a meteorologist, you've got to have an interest, or maybe not a high interest, but you've got to have an ability to do math pretty well. And you also have to have an interest and ability to understand physics or general physics, because that is necessary to understand atmospheric science. So those are a couple of critical things. But meteorologists aren't the only ones employed by the National Weather Service. We also have positions for computer programmers, which also require a bachelor's degree. We have positions for those who work on the sensing equipment that we use for gathering weather data. Those are what we call electronic technicians. Those do not require a bachelor's degree, but intensive training a little bit probably beforehand, but more once you join the Weather Service. We also have positions for what we call maybe assistants to the meteorologist. They're called hydrometeorological technicians. Again, no degree is required for this, but they do help in compiling weather data that comes into the office and answering phone calls from the public. It has information, so that's another avenue. And plus we have, each office needs someone skilled in administrative functions to organize reports and do those types of things. So there's that opportunity as well. And there's also, in some selected weather offices, engineers are needed as well.
And this next question touches base on how meteorology relates to life in the villages and where people live. The question is, what does the National Weather Service do when there's a natural disaster? For example, a severe snowstorm is predicted. Who does the National Weather Service contact?
Oh, good question. This is part of my job in a way. Not that I do that every time a storm warning is issued, but part of my job is to communicate and contact with people ahead of time. Weather warnings are distributed to people at the time they are issued to the people who need them. So we have offices in Barrow and Nome and Kotzebue that we work alongside with, and while they don't do extensive forecasting like is done in the Fairbanks office, they are our relay office to communicate the weather information and warnings to the various officials and people around in not only the cities that they're in, but also in the surrounding villages. So we issue a warning from the office. It goes out through communication circuits so that the radio and TV media have access to them, and we notify our office in Nome or Barrow or Kotzebue, and they relay that same information to selected people in each village. Normally those involved with emergency response or the village public safety officers, those type of folks. That way, the word is spread out rather quickly.
John, part of our program with Arctic Climate Modeling Program is students collecting weather data. And some of that is automated, but some of it is collected by the students. For example, data on snow depth and snow cover, sea ice, those types of things will be collected and archived. What's the significance of having those records long term?
Oh, it's very significant. There are many places in Alaska for which the weather and the long-term records, being climate, really don't exist. So in those places, it's really great to start a record and to keep it going as long as possible. Once you start a data set, for instance, just snow depth, for instance, that can be tied into nearby areas that already have a long data set to help understand how that new site fits in with all the others. And it can help make a more detailed image. It's kind of like taking a picture with the focus out of whack and then moving it towards getting it focused, but not completely. And every time you add a new site that's collecting data in a steady, reliable way, then that's helping to bring more focus into the picture. So every piece of good data helps.
And the last question, John, is what do weather balloons measure and how are they launched?
Weather balloons measure temperature and humidity, and they also measure the pressure, and they're used as they're tracked as they ascend through the atmosphere. They're also used to calculate wind speed and direction. Now, they're launched at about I believe 14 different locations in Alaska. One of those is Nome, and the folks at our Nome office will launch a weather balloon once every day. Right now it's at the 3 o'clock hour, or they actually release it at the 2 o'clock hour. Once we go to daylight savings time, they'll release it at the 3 o'clock hour. That's because the launch takes about 2 hours for the balloon to ascend all the way up into the atmosphere. And they need to have the data centered around the 3 o'clock hour right now, or the 4 o'clock hour once we get to daylight savings time. So they launch the balloon, and in this box that's tied to the balloon is a sensor for temperature and humidity. There is a transmitter that will send this information back down to a receiver at the Nome office. And and also a pressure sensor. And this is all transmitted back to the Nome office as the balloon goes up higher and higher. And this is received at the Nome office, and there's a known amount of helium that's put into each balloon. With that, the calculation can be made as far as the wind direction and the speed, because the receiver is actually tracking what direction the balloon is going as it ascends into the atmosphere. The balloon goes up to maybe 55,000 feet typically before it bursts. It just gets too big, and the material the balloon is made of finally stretches enough that it just bursts, and the balloon and the instrument falls back down to Earth. There's a little parachute on the balloon. It opens, deploys, that is, and so it's the whole assembly drops down to Earth rather gently, so it doesn't hit anybody severely on the head. It wasn't expecting it. And the balloon and the parachute are biodegradable. The instrument stays like it is until somebody can come across it. Usually by randomly, we don't send people out to retrieve the instrument because the data has already been transmitted by the time the balloon bursts. But the instrument is mailable back to a facility down in Kansas City where they actually make new transmitters.
Thanks for tuning in, and hopefully we'll meet up with some of the teachers in just a few minutes. Back. The first question is, today's topic was data display. What's a good age group to get children working with displaying data, or is there no necessarily starting age group? Those types of questions that teachers may have.
Well, I would imagine you could probably start in the upper elementary grades in general, but saw an example recently, now the second year in a row, where a school here in Fairbanks, in fact it's the one that my daughters have attended, have a graphing skills program where each grade is involved from 1st through 6th, and they have a night to display their work, hard-earned work, to the parents. And so even the first, second, and third graders were taking surveys of some basic information and then making plots and graphs and bar charts of that in comparison. And so I guess really the answer is it's never too early to start.
The next question is, do you have any favorite weather experiments or types of things that you can do with children to get them learning about the weather? Hands-on types things. Does anything come to mind as far as favorite experiments or activities to do with children?
One of the things I like to do when I can provide the setup is to use usually you need a deep dish Pyrex bread pan. So it's all glass, and it's a bread pan, and you fill it with water, and then you have have one end of the bread pan sitting on top of a bag of ice, and have the other end either under a pretty good coffee cup warmer or something that has a fair amount of heat, maybe even just a small flat candle, heating that side of the water in the bread pan. And then I take food coloring, a bottle of red food coloring, and put one drop into the bottle underneath where the water's being warmed. I take blue food coloring and put a drop into the water where it's being cooled, and you can watch how those two colors intermingle. In general, the red will probably spread out at the higher elevations of the water or nearer to the surface, and the blue food coloring will spread out across the pan in the lower elevations, which kind of help model the warm and cold air masses. So what you need for that, again, is a Pyrex bread pan, red and blue food coloring, a source of heat for one end, and a source of cold, like a bag of ice, for the other end of the bread pan.
As we're talking about education things, as far as like with NOAA or other types of organizations that may have educational resources available, like on the web, that type of thing, is there any direction you could point teachers in as far as resources or a place maybe they could go on the web and find such experiments like that?
Yes, if you go to the main NOAA website, that's right, www.noaa.gov. There should be a link, it's probably on the left-hand side, about educational resources. And of course NOAA encompasses more than just weather. The National Weather Service is one agency under NOAA, but if you want to look into the oceanographic type of the environment, that's another good place to get some educational materials as well as the weather educational materials. And actually, if you type into your web there, www.weather.gov, I believe that there also are some educational links of our own that the National Weather Service has provided as well. So those two sources are easy ones to go to.
The next question, John, is what made you choose working with the Weather Service in Alaska? Coming from Oregon, why did you choose Alaska?
Well, that was more of a pragmatic decision. At the time I applied for the Weather Service, it was through the government agency called the Office of Personnel Management, and you could apply for a variety of different positions there. in the science category, of course, one was meteorologist with the National Weather Service. So I kind of applied through that route. At the time,
So, John, you were speaking about the working with the National Weather Service and the opportunities you had here in Alaska.
right, so at the time I applied, the only place for entry-level positions, which is what I only could qualify for, was Alaska. So I selected Alaska in hopes that I could get a job soon. I applied in December, and I was called in December of 1979. I was called in March of 1980. So it didn't take too long.
The last question we have is, what opportunities do studying the weather and climate give teachers and students to learn about science? What are some of the main things about science they'll learn by studying atmospheric science or the weather?
Well, certainly weather is one of the key components of what they call earth science, and so you can certainly fulfill an earth science requirement through that. Weather is, a lot about data, as we just discussed, and data requires calculations, so you're also honing some math skills as well with your students by looking at data, making comparisons. You're doing charting and graphing like we discussed today. So there's a variety of facets that studying the weather can help fulfill in educational requirements.
Well, thanks, John. We're going to wrap up at this point. We appreciate you coming on with us today and taking time to interact with the students and the teachers.